Hi everyone, and good evening. Thank you for taking your time to join our live webinar today. My name is Ivy, and I look after BenQ LCD monitors. And I will be your co-host in this live webinar with our main host, Jeremy, the director and owner of Image Science. And I'm excited to have one of our specialized partners in photography monitors help us in hosting this live webinar. Image Science provides expert advice and unmatched after-sales support to photographers and graphic artists seeking to achieve color accuracy in their work. And they have been in the industry for over 17 years and specialize in fine art printing, film scanning, custom profiling, art reproduction, and more. For complete beginners to Australia's finest artists, they have constantly offered the highest quality and friendliest services available every time. So we will go through some topics. Next page, please. Some topics in our webinar today. And Jeremy shared his knowledge and experience managing color from screen to print to achieve perfect results like artists such as Mark Induso and Jeremy Geddes. And your files as a complete specification for your prints, including file types, bit depths, and correct image resizing and layouts, and color collaboration and accuracy. Why you need to see accurate color so you can specify exactly what you want to get, and color proving, including ICC profiles and traditional soft proving versus hardware-based soft proving. And Jeremy also received a large amount of topics in advance from some attendees, and he will try to cover as much as he can here. So feel free to ask any questions in the chat room throughout the webinar, and we will get back to you at the end of session during Q&A. And a reminder, there will also be a quick survey once the webinar finishes. So if you could please provide some of your feedback, that would be greatly appreciated and will also help us for future webinars. So now over to Jeremy.
Hi everyone. As Ivy said, my name is Jeremy Daalder, and I'm the co-owner with my wife of Image Science. I think, based having had a quick look at the participants, many of you are customers of ours and friends and colleagues, so welcome. It's nice to be with you. Hopefully you will find something of interest tonight. As I was saying to Ivy earlier, one of the hardest things about doing a talk like this is always picking the level at which to pitch it. I have probably erred on the side of simpler rather than complicated. Color is without doubt one of those things that can get very complicated very quickly. But really something that I've noticed year after year, and I've been doing this for about 20 years now, is that the people make the same mistakes over and over and over again with really basic things to do with file setup when it comes to getting things ready for print. So for some of you, this might seem a little bit simple as I begin. Hopefully we'll flow into the more interesting stuff towards the end. But stick with me. The idea is to present it in a way that really takes us all back to first principles and really looks at digital files as a specification or as a system for specification. All right, so I'm going to share my screen here to get my slides going. I haven't actually done a talk with slides in some time now, so can we see that? Let me just, Ivy, can you just nod your head if you can see that? My slides. No, you can see yourself at the moment, can't you? I can't do that. There we go. All right, here we go. Sorry, I just need to share my screen, don't I? Sorry, there we go. Here we go. Okay, now you should definitely see the slides. Okay, and now, yep, you can. Great. All right. So let me just click there. So let me move. No worries. Okay, so I guess the question is, what problem are we actually trying to solve here? Starting right at the beginning, you know, there is a common refrain in photographic circles: if you haven't printed the image, it's not even a photograph. And, you know, I think for almost every photographer, and certainly pretty much all the photographers I encounter, there is still a very strong urge to complete the art of photography, to really take a little bit of the world, capture it, and produce from it this beautiful art object that is the print. So that, you know, is the goal, and that's what I'm all about, and that's where I'm coming from. So let's take it as a given that we want beautiful, accurate prints. So the real question is, how do we get what we want? And really the best way to get what you want, both in life and in printing, is to ask for exactly what you want. So, you know, getting the right results with print is really a problem of specification. How do you specify precisely what you want? This is, you know, just the same as having a house built. You know, you might have an architect, you might have a builder, you might even have multiple builders along the journey. But basically, from the architect's design and your wishes, there will be a lovely set of blueprints produced. And then in theory, you should be able to give those blueprints to any builder, and the builder can take that and build you what you want. It's having those great blueprints that gets you what you want. And your job as a photographer, when talking about print, is to do the same thing. You need to create the blueprints for a marvelous print, a really precise specification of what you want. I'm going to use some shorthands tonight, just to, you know, I'm going to talk about send to printer. Now, really that applies both to sending to a printing service or sending to your own printer. The problem for both of those things is exactly the same. You need to specify what you want, whether or not you're using a printing service. It's exactly the same process. It's all about creating a digital file that tells either your printer or the printing service exactly what it is that you really want to receive. And I'm going to use Photoshop as a shorthand for imaging applications. Nothing I say is specific to Photoshop. If you're using Affinity, Lightroom, Capture One, whatever you like, it's just, you know, standard industry parlance to use Photoshop in that way. So what are we not going to cover? We are not going to cover photography itself, or, you know, how to take a nice photograph, how to compose something, how to construct and then edit an image in aesthetic terms. You know, if you want to do a course in photography, you're going to need a lot more than 45 minutes or an hour. You're going to need, you know, something other than this webinar. We're not going to talk about color management at the capture end. So building what are called input profiles. We're not going to talk about how to manage the color coming out of your camera and so on. The reason for that is that photography is very rarely actually about technical accuracy at the capture end. It's all about pleasing. And, you know, the entire modern photographic workflow isn't actually built for accuracy at that capture end. It really is built for pleasing. It is, in fact, for those of us who sometimes do want to achieve accuracy, it's a little bit frustrating how inaccurate some of the modern tools are. Things like Photoshop, and particularly Lightroom, they're built to produce pleasing results rather than accurate results. Now, there are systems, if you're doing a type of photography, such as art reproduction or product photography, where you really need accuracy, but they, you know, that is really a set technical domain, and I want to stick to more general things tonight. So really, you know, this is the art of choosing what you want to present from the world as a photograph and then specifying that properly to your printer. You know, even if you do want to achieve real accuracy in a sort of more technical sense, such as in art reproduction, it's more important that you see what you have than per se that you actually capture things accurately. The reality is that digital camera sensors or scanners, or however you're inputting your image, they will always see color in a way that's quite different to the human eye. So that even with the best tools and the best capture color management, you still end up needing to see what you're doing and to see the color that you have captured accurately. That is the key thing. Now, you know, this talk is only about an hour into it's to a general audience, so I'm just going to stick to really key points. I'm not going to go into a whole lot of depth simply because there isn't a tremendous amount of time. If you do want to get into the nitty-gritty of all this and really understand things like color management and so on, we have an asset on our website called the Digital Fine Print ebook. So you can see the website here. And basically, if you go to Knowledge and you click on this ebook, The Fundamentals of Digital, it will take you through to a large free resource that covers all of the sort of things I'm going to talk about tonight, and a whole lot more, and in a lot more detail. Now, this little bit is inevitably going to sound salesy. Not surprisingly, this is a BenQ webinar, but it's also true. You simply cannot achieve high quality results with print. You cannot specify what you want and get what you want with print if you cannot see what you actually have and what you're working with. It's simply impossible to look at inaccurate color, to be editing inaccurate color, and somehow hope that at the other end you're going to miraculously achieve an accurate print. So, and I've done entire webinars on monitors and calibration, but the simple reality is you must have a high quality monitor and you must keep it calibrated if you want to achieve these sorts of things. 20 years has shown me that people will endlessly muck around with low quality rubbish from places like Dell and Acer and those sorts of things, and spend an awful lot of time, or waste an awful lot of time using the wrong tools, not seeing the color that they actually have, and therefore making poor editing decisions. And that flows down, that you'll never get good prints. So, BenQ have a marvelous range of affordable color accurate monitors. They are really, I think, have nailed the price performance dichotomy, shall we say, and a BenQ monitor combined with a highly accurate calibrator like the i1 Display Pro, which is really the only sensible calibrator choice. Together, those things are a cost-effective tool that costs about the same as a single lens in your kit, but you will use for literally every image you ever work on, and you will be able to look at and see what you have. And that is an absolutely key part of achieving good color. If you have questions, this being Zoom, there is both a chat channel and a Q&A channel. If you could put your questions into the Q&A channel, that would be great. Not so much the chat one, it gets a bit busy in there sometimes. With the questions, if you could aim for questions of general interest, it would be great. Sometimes at these webinars, we get some really specific technical support questions coming through, and there are a few hundred people, watching the webinar, and obviously not all of them are going to be interested in your particular tech support issue. That said, I'm completely happy to answer those sorts of things, but after the fact, if you use the website to contact me, I'll be more than happy to go through your specific technical problems. Okay, so the goal is to go from files to beautiful, accurate prints. And we're going to assume that you have that you've been convinced that you very sensibly have got yourself the key tools, a high quality monitor and a high quality calibrator. You're calibrating regularly, and you are therefore at least seeing what you've captured, whether or not the camera has recorded that accurately. So let's look at how we are going to specify precisely what we want. As I say, our main business is fine art printing. It's really at the core of everything that we do, everything that we sell. And over the years, for 20 years now, I have seen people make the same mistakes over and over and over again. People who often should know a little bit better. It's as somebody who has worked in photographic education for quite a few of those years, I am constantly frustrated that pretty much none of the photographic courses here in Australia, for example, actually include any basics about what digital files are, how they record color, what a pixel is. All the really basic types of stuff is just not covered in most of our courses. There was briefly a really nice course at RMIT, but that has unfortunately disappeared and been absorbed into the general course. There simply isn't enough about this stuff. So I have a real bee in my bonnet about teaching the basics of what digital files are and how you use them to specify things, because I found that is the most effective way. When people really understand that, they get much better at achieving the things that they want with those digital files. That's what we really want, is no alarms and no surprises. We don't want things coming out of our printer. We don't want to pay a printing service to produce something that is just not what we expect and not what we want. So let's talk about a digital file, a digital image file specifically. I'm going to talk about photos, but everything I say here, if you happen to be an illustrator or you happen to be a graphic designer, you're creating new works in Procreate, you know, people are doing all sorts of great things in the digital art world at this point. If that's you, everything I'm talking about is just as relevant to you as it is to the photographers. My domain, my background is professional photography. So, you know, that's where I'm coming from and that's how I'll sort of present it. But be assured that if you're working in any of the visual arts, this same stuff applies to you just as much as everyone else that's listening. And here we are really talking about taking one digital file and producing from it one great quality print. We're not talking about the more general things such as creating a book or desktop publishing or anything like that. So, starting right at the beginning and in the simplest possible terms, a digital image file has only really one static permanent property, and that is that it is an X by Y grid of coloured dots known as pixels. This is called a bitmap file, as opposed to, say, vectors, PDF container files, that sort of thing. A bitmap digital image file is simply an X by Y grid of coloured dots. And that's great because really that's exactly what we want. We want this grid of dots because it is the most precise way of specifying what you have in the file, so to speak, because there's little to no interpretation of that required. So, for example, if you're using vector files, those vectors ultimately have to be translated at some point into pixels, and different programs will translate those vectors differently, so you can immediately run into problems, which is why using a vector file is a really bad idea if you're trying to specify something for print. You want to use a bitmap X by Y digital grid of colour dots. And really that X by Y, as I say, it's the only fixed property about your image. The X by Y, as in what those numbers actually are, that's determined by the resolution of your camera. So, for example, your camera might shoot 6,000 by 4,000 pixels, or it might shoot 8,000 by 600. It's a fixed property. It's what comes out. It's what you got. If you don't crop the image, that is the X by Y that you will have. If you're scanning in, it's what comes off the scanner. If you are creating new documents, digital art, for example, it is how you create the document initially in your tool like Procreate. You specify the size of the image that you want, and you specify that size in pixel terms. More is better, no doubt about that. But obviously, this is really simple stuff, but that is what a digital file is at its core in the context of everything that we're going to talk about. Everything else that follows, file formats, bit depths, size tags, they're all secondary things. So the real trick here is to make sure that your X by Y grid of pixels means what you think it means. So I'm just going to go through the basic file types that are relevant for this conversation, just so that we're all talking about the same thing. So the first file type that I'll go through is RAW. So RAW is the modern digital negative that comes out of digital cameras. Anyone interested in photography is going to be shooting RAW. They're not going to accept the rendered JPEGs out of their camera. They're going to take this marvelously malleable, flexible thing that is the digital RAW file, and you're going to bring that into your RAW converter, and that is where you're going to do the bulk of your adjustment of images. It's the least damaging and most reversible place to do your adjustments, but it is an unrendered file format. So again, it's this digital negative plus a layer of adjustments on top that creates the ultimate image that you're seeing on screen when you're in your RAW converter. The problem with that is that layer of interpretation. It is a really bad idea to take a RAW file and send it straight to your printer, to your printing service, because that layer of interpretation is potentially is an error area. It's going to be a part of the process where the printing service, for example, might make a different decision, a different interpretation than you expect, and therefore you won't get you want. So it's an inappropriate, as an unrendered file, it is an inappropriate format for specifying anything for print. At some point, your RAW converter has to turn it into that XY grid of fully rendered pixels, and that is precisely what happens if you print directly from your RAW converter to a printer. That's happening in the background. What we really want to do is control that part of the process, that rendering part of the process, as explicitly as possible, so that once we have what comes out of there, we have this fully rendered precisely specified digital file. And it is that we then want to pass on to a printer, be it your own or a printing service. As a side point, I never understand why people would like to send a raw photograph to a printing service, but we do get asked that reasonably regularly. I don't actually see the point in being a photographer if you're not doing your own raw processing. A huge part of the modern digital photographic workflow is the decisions that you make in the raw processor. More than anything else, that determines the look of your photograph. So for me, that's an essential part of the control, and you should only be passing on to your printer that finished, fully interpreted file, which leaves no room for further interpretation. So when you export from your raw converter, what format should you export to, and what format should you use in the more general sense if you are creating digital images in another way? Well, the obvious answer to that question is the TIFF. This is a file format that has been in use since I was a young boy in the mid-80s, and it is compatible with everything. It is not a compressed format. There's no damage caused to the image when you save it, which is something I'm going to talk about in a sec. It is, or if it is compressed, it's losslessly compressed. But a flattened TIFF file, and that is important, TIFF files can contain what are called alpha layers, which is basically meta information about a file. What we want to do is create a fully flat TIFF where there is just one grid of pixels, X by Y, of colored dots, but it is saved uncompressed. It is something that you produce after the raw stage of the editing process. It is the ideal file format to use to supply things to printers. If you're also storing, generally speaking, the workflow is that you do global adjustments on your raw file. You then export to TIFF and you do localized adjustments, very precise retouching on a pixel type level. And then you save that TIFF file as your master file. You might import that back into your raw converter for convenience, but it is a TIFF file at that point. It's a fully rendered thing. You don't always have to do that. You can obviously store, if you're not doing pixel-based editing, you can of course store your images just as RAWs. That's fine. But when you then pass them on to a printing service, you must, or you really should, produce that fully rendered TIFF file. JPEGs are the other one that really come up. Obviously, everybody knows the modern JPEG. They're ubiquitous. They are a problem, basically because JPEG is a damaging type of compression. It makes the file drastically smaller, and it does so by removing information that it considers, superfluous. It's absolutely fine to do that once, simply to export or resave your file as a JPEG for transmission, for emailing, for sending to the print service, simply to save some time so that the file isn't so big. But you only want to do it once. And time again, I see people making this very fundamental mistake. They will send us a JPEG that has quite clearly been edited and resaved multiple times. This is one of those things that I like to show to people because I don't think they fully realize what an impact this has, and specifically on color. So, for example, if we take an image here, like many people during the pandemic, I've become an amateur bird photographer. So here is a picture of a fairy wren, and this is taken straight from my master TIFF file. If I then decide to send that to a printing service, I would typically export that as a quality level 12 JPEG, the highest quality level. I would do that only once. I would never re-edit that JPEG, and I would send it to the printing service. And if I were wanting to be really careful about it, I can analyze the difference. I can use Photoshop as a tool to analyze the difference between my original TIFF file at full quality and the created JPEG file that I've created from it. And when I do that, this is an example here. You can see, hopefully, that you have very, very little difference between the JPEG and the TIFF. So this is an image that shows only the difference between the two. There is some difference, but you can see it's just in those very deep shadows. It's not in consequential parts of the image, and almost all of the picture is the same. Now, say I then proceed to make a few adjustments to my file. I save it. I realize I've got the sizing slightly wrong. I save it again, and before too long, I've done that, say, 3 or 4 times. That might produce this. This is the same image, but I have saved it multiple times as a JPEG. Now, to the eye and across Zoom. I'm not sure how well Zoom will communicate this. It doesn't look that different. You kind of might find yourself thinking, oh, it looks basically the same. There's no major problem there. But if we now analyze it again back against the original file, now you can see that everything has changed here. You know, you can see that all of the fine detail in the bird, all of the fine detail in the branches and so on has now changed quite significantly. That's a big problem. That will begin to affect print quality. So we really want to avoid that. We only ever want to do that JPEG process once. But something that's also not obvious about that process is, you know, there's been some pixel degradation, i.e. to the fine detail. But what many people don't realize is there's also a weird color shift that occurs when you start doing this because of the way the JPEG compression works. So if I present the two files side by side, again, I'm not sure whether Zoom is going to show this, but hopefully you can see the two changing quite significantly in color between the two images. You know, for example, the little stick directly under the bird has gone from essentially green in the first photograph, or at least a natural brown, and all of a sudden, after just saving it a few times in JPEG format, it's actually gone a really, you know, unnatural orange color. So not only has the JPEG compression impaired the image detail, but it has also actually affected the color of the image as well. And while I might not even notice that if I'm just sort of working on that image and so on, if I go back and compare it to my original, it's distinctly different, not just in fine detail terms, but in color terms. So your take-home point about JPEG is only use it as a final save or export option to send your image away, and never ever go back to that JPEG and edit it and resave it. It's a very damaging process. Bit depths. Bit depths is a really confusing topic to many people. That is not surprising, really, because there's so many bit depths involved in the model, in the digital imaging workflow. You've got the sensor bit depth of your camera. You've got the bit depth of the file that you're storing your images in. You've got the monitor signal bit depth. You've got the LUT or lookup table bit depth of the monitor. You've got the profile bit depth of your printer profile. Most of those bit depths you can't really control. They're fixed physical properties about the hardware you have. And most of them don't make nearly as much difference as people seem to think they do and worry about. The one that really does make a difference, it is critical, is the file bit depth. So the bit depth, put simply determines the range of values that can be used to store the color. And basically we want more bit depth. We want more possible discrete levels of color, and we achieve that by having a higher bit depth file. So in 8-bit maths, the range of values you can store for an individual pixel are between 0 and 255. In 16-bit, the range of values are between 0 and 65,300, whatever it is, 65,536. Hopefully you can immediately see that there are just vastly more possible color values in a 16-bit file than there are in an 8-bit file. Now, why is this important? And this is, you know, what people often don't really understand. Everybody thinks more is better, or, you know, and that's fine, but let's have a look at why it's better. Firstly, it's important to understand that all digital image editing is, in a sense, damaging. You know, you are taking a group of color numbers and you're doing some sort of mathematical process to them. I mean, to you, when you're editing, it seems like a visual process. You know, you're adjusting brightness, or you're increasing saturation, or you're adding a little bit of warmth, or getting your white balance right. But in actual fact, you know, what's going on in the background is maths on the color numbers. And the more maths you do on your color numbers, the more likely you are to run into color problems. This is particularly true of 8-bit files, much less true of 16-bit files, and I'll show you why. But one of the tricks that I have done, and I think that makes me a better retoucher than many people, or historically has, is the fact that I will very often edit a file and spend a lot of time on that, really, you know, tweaking lots of things, trying different looks and appearances until I get it just the way I want. And then most people stop at that point. They save their file and they go, okay, I'm done. What I do is I actually go back to the original file and I re-edit it to the destination point, which I now know, I can now visualize because I've got it there on screen, and I've got another copy that I'm re-editing. And I re-edit that file right from the beginning to the edited version using the shortest possible path, because now I know what I'm aiming for. I can make better decisions about how to get there, and I use less edits. And what that tends to result in is a purer expression of the same image. You can often see, particularly in areas like deep shadows, that you have achieved the same visual effect, the same contrast, say, the same whatever it is that you're going for, but with less damage to the difficult areas of your file. So let's just have a quick, this is one of my favorite examples. It's boring in its numbers, but it's very effective at showing you what the problem is. It's slightly contrived, but it demonstrates the fundamental issue in a low bit depth file. So say we have 3 colored pixels, and they are, and we'll just talk about brightness at the moment, but they're at the brightness 9, 8, and 7. So 3 pixels with 3 subtly different brightnesses. If we now want to dodge them, i.e., sorry, burn them in, I should say. I've written dodge there, but I actually mean burn them in. We want to make them darker by essentially 50%, let's say. If we do that, let's look at what happens to those numbers. Well, computers only deal with whole numbers, with integers. They don't do fractions. So if I take my 9, my 8, and my 7, and I divide each of those by 2, the result is I have a 4, a 4, and a 3. So the 9 divided by 2 becomes 4 because of rounding. The 8 divided by 2 is also 4. And my 3 pixels that used to be 3 separate colors in one operation are now 3 pixels, but only having 2 colors. You know, 2 of those pixels are now the same color. This is known as bucketing. It's exactly the mathematical thing that leads to banding in images, which is something that you tend to see in scenarios where people have edited too heavily, or where they have edited an 8-bit file aggressively. If, on the other hand, we look at doing the same thing in 16-bit maths, well, sorry, going back a step, if you imagine that example multiplied out by a whole bunch of pixels in your image, you can see quickly how all these nicely different colored level pixels have turned into a mushy, muddy mess, because many of the pixels have landed on the same colors through this mathematical transformation. If we instead now look at 16-bit maths, you know, I've just made these numbers up, but those pixels might then have a value of 180, 160, and 140. If we do the same operation to those pixels, we divide their brightness by 2, say, we're left with 90, 80, and 70. You know, we still have 3 different colored pixels at the end of that operation. In fact, we can do it again, 45, 40, 35. Do it again, 22, 20, 17. Eventually, even with a 16-bit file, if we just keep on editing it and keep on applying the same operation over and over again, we're going to run into the same problem. But even with this simple contrived example, you can see how much more tolerant a 16-bit file is of editing adjustments. That's the mathematical explanation, but it's one of those things you can easily test visually if you care to try it out on an image. But that is why we want high bit depth in our files. And when it comes to talking about bit depth, that is the crucial one. You want to make sure that when you export your images from Lightroom to Photoshop, for example, that you choose 16-bit and so on, and that you don't accidentally convert to 8-bit. That's another good reason not to use JPEGs, is that JPEGs only come in 8-bit. You can't create a 16-bit JPEG. It's not part of the JPEG specification. So you are instantly losing some of your information in the JPEG world. I want to address 10-bit input and what are called true 10-bit panels, because I get so many technical support questions about this. It seems to be something that people really obsess over and are deeply interested in. I will tell you, as I tell everyone, I have literally never seen 10-bit input into a monitor or true 10-bit panels or anything like that make any practical difference in a retouching scenario in a professional context, ever, not once. You know, it's nice to get 10-bit working, and I can see why people want to achieve that, but the reality is that fair chunks of Photoshop, for example, are not implemented in 10-bit. You'll use an operation, you'll make some sort of adjustment, and Photoshop will simply switch back to 8-bit display in the background. It won't tell you, you won't know. And you know, all of this time and money you've spent on fancy video cards and so on, trying to get 10-bit working in terms of communication to the monitor, is essentially wasted. It's just not a big deal. It is not the core feature that you should be looking at in a monitor. You should be looking at accuracy. What is the overall accuracy of reproduction? How uniform is the panel across its display? Those sorts of things, the sorts of things that BenQ and ASO and so on, those high-end monitor brands are really good at, and the sorts of things that Aces and Dells and Apples, all of those sort of rubbish office brands are not good at. But 10-bit at the input end and so on, it's just not worth spending a lot of time on. Now, at this point, just as a quick review, we have talked about the basic XY grid of coloured dots, and we are now hopefully storing our images in an appropriate non-destructive file type at a high bit depth, a 16-bit tip, or perhaps we're leaving it in RAW. This file, right, specifies the image content in colour terms, and of course we're going to come back and talk about that in more a little bit later. But let's move on to the next most fundamental part of digital files, which is how big, when moving a digital file into print, the next most fundamental thing to address is the size of the print. It's really important to understand, and this is, I think, it's a common area of difficulty for people. The size of your image is really just a tag, a little piece of metadata that is stored in the image. So it's really good to remember all you really have is a fixed number of pixels, X by Y. And if ever you're getting confused about image sizing, always just go back to that basic information. What is X? What is Y? How many pixels do I have? And Photoshop or other imaging applications will attach a tag to the file specifying a desired size that you want the image at. It's just a little bit of metadata. It makes no change in actual fact to the content of your image. It is really a crucial thing to understand. People are always saying to us, my file is 14 megapixels at 300 dpi. That really doesn't mean anything. It doesn't tell me how many inches that you want the print at. It doesn't actually tell me anything particular. Or if you say, I've got 40 megabytes. If your file is 8-bit, 40 megabytes might be a lot. If your file is 16-bit, which means you're using twice as much data for color, the pixel dimensions haven't changed, but the file size has. Megabytes, megapixels, all of that stuff is essentially irrelevant. You want to go back to the number of pixels you actually have. So really, when we're taking a digital image, this X by Y grid of pixels, and we're producing a print from it, what we're doing is we're mapping pixels to inches. We're taking the fixed number of pixels that we have, and we're saying, I want to use this many of them to produce 1 inch of print. Now we could go crazy and we could say, I want to use 1 pixel to print 1 inch of image. With a modern digital SLR camera, and you've got 6,000 by 4,000 pixels, that means you would be saying to your printer, hey, I want an image that is 6,000 inches by 4,000 inches. No one is actually going to do that. You could do it, but you would have a blocky mess of an image. No, obviously we want to use more than 1 pixel per inch. We want to take some chunk of pixels and translate that into an inch of our print. And I do use inches here because for better or worse, the entire print industry uses this expression pixels per inch. In actual fact, they often use the incorrect expression of dots per inch, which I will talk about a bit later. But it's always inches, never centimeters, which is a bit of a shame, but here we are. Okay, so we have an X by Y grid of pixels, and a very common question then is, how big can I print my image, given that that's what I have? And I mean this, I do mean this in the nicest possible way, but literally every day, somebody sends us an image and says, hey, how big can I print this? This is really something you need to learn. If you want to work with digital images and photography and so on, you need to know how to look at your image and work out how big it is and what you can do with it. It's not something that you need, to send off to a service for their considered opinion. this is simple maths. You know, this is just basic arithmetic that will tell you how big can I take this file and print it. And Photoshop has a handy little calculator tool for us, which is the image size dialog box. In a nutshell, to work out how big a print you can make, and there is more to it than this, but without going into too much detail, the basic recipe is X pixels divided by a figure for pixels per inch will tell you how big you can print your image horizontally. Now, how many pixels per inch gives you photographic quality? Well, the commonly affected modern figure is for a low ISO sharp shot, you know, one that you've actually shot in focus without camera shake and so on. You need about 240 pixels per inch to achieve a sharp photograph. In the old days, people used to go on about 300 pixels per inch. That largely came from the era of film scans, where you had grain getting in the way, you had noise, and so on, which you know, meant that you had a lower signal to noise ratio and you needed a few more pixels per inch. So the modern accepted figure is 240 pixels per inch. So as an example, if we go over to Photoshop here, we have a picture of the fairy wren here. We can work out how big we can print our fairy wren by using Photoshop as a calculator. You know, again, if I type in 1 for the pixels per inch figure, it will tell me I can print this particular image 4013 by 3010 inches. And that is because I have 4013 by 3010 pixels in this image. Stands to reason. If I say, okay, at pure, excellent photographic quality, using this sort of standard figure that people have agreed on of 240 pixels per inch, I type that into the resolution here and Photoshop calculates for me the size, the physical size I can print this at perfect photographic quality. In this case, roughly A3, 16.7 by 12.5 inches. Now, if I wanted to achieve a print that was bigger than that, you know, I really wanted to print this, you know, I don't know, poster size. And I know that poster size is, you know, roughly 24 by 35 inches or 80 by 60 centimeters in the modern. I can say, okay, I want to print this at 35 inches wide. It will calculate the corresponding height for the aspect ratio for me, 26 inches, and it will then tell me how many pixels per inch that works out at. So my X by Y grid of pixels, if I were to print it this big, then 114 of those pixels would map to 1 inch of printed area on the photograph. Now, that might be acceptable or it might not. You know, the reality is, as you go below the figure of 240 pixels per inch, you move away from perfect photographic quality. You will get a less sharp result. Will, if you're looking at the print from a close-up distance, you'll begin to perceive a lack of quality. But it might well be acceptable to you. There's no hard and fast figure, but you know, you can certainly say at 240 pixels per inch, printing this at A3 size, I will have a pin sharp photograph because it is a sharp image in focus. Back to that one. Right, sorry, I'll stick to Photoshop here. One of the important things to notice about what I was just doing here was I took great care to make this box here, resample, was not checked. Resampling is possibly the most dangerous operation you can do to an image. It is the #1 way people stuff up their file preparation for print and create problems and essentially create irreversible damage to their digital images. So the first thing, oh yes, hello.
Sorry to interrupt.
No.
We can't see your Photoshop screen. So can you?
Oh, you can't see the Photoshop screen.
Yeah.
Okay, no worries. Hang on, let me. That's no worries. Sorry, I'll have to reshare because that probably means I shared a particular window rather than sharing the whole thing. Sorry, that's screen share. Okay, let me try that. Richard, sorry, can you see that?
Yes, now is okay.
See that now. Okay.
Yeah. Okay,
Is it worth much? Should I just go? Well, I'm going to go over the calculator thing in this second part anyway, so that's all right. Basically, this is the image size dialog box, and I was typing different numbers into here. For example, 35 inches. That is how it then calculated the height and, most importantly, the resolution that I had from my file here. That is Photoshop's handy little calculator that really tells us the quality and therefore the print size that we can achieve from a particular file, and how much quality might be dropping. Now, as I said, I took great care not to have the resample box ticked while doing this operation. And that is because resampling an image, very good at that apparently, resampling an image is quite simply the most destructive, really, operation that people do in Photoshop on a regular basis, and you know, stuff things up basically. Resampling means essentially taking my original source image and creating from it an entirely new image where we either add pixels or take pixels away. Now, obviously, that's a drastic operation. You know, we are creating an entirely new calculated image from the source image, from our original image, with a completely different X by Y grid. And if we're not very, very careful about that, we can end up accidentally throwing away a great deal of information in our image if we inadvertently reduce the number of pixels that we have, or we can accidentally add a whole lot of useless pixels that do nothing but soften our image and create a unnecessary use of storage space. They really do add nothing to the image. So you need to be really careful when you resample. And the golden rule when sizing an image for print is to first resize, and then, if there is a reason to, resample. So just as a quick example, going back to Photoshop here, if I had my image and I decided, okay, I want to print this image as an A4 image or as a 10 by 8 image, so 10 inches by 8 inches. So I type in 10, my aspect ratio is not exact, but I'm not going to worry about that for the moment. And it tells me that I have 401.3 pixels per inch. Now, I might know, as I do, that that is a resolution figure that's too large for my printer to get any benefit from. So after I have done the resizing part, and here I click OK, first I lock in the resize part of the process. I then come back into image size. Now, you don't have to do that. I just do that because it's an effective mental technique to make sure that I'm really explicit about what I'm doing in each step. At this point, I might then decide to resample my image down to 360 pixels per inch because I happen to know that's the native print head resolution for an Epson printer. So the ideal pixel per inch value for an Epson printer. And then I click OK, come back into here. You couldn't really see that, but what it did was it created an entirely new image from the source image at the resolution that I fixed, that I chose, that I resampled to. And you can now see that my image that was previously 4,000 pixels by 3,000 pixels is now only 3,600 by 2,700 pixels. So it has thrown away information. Now, I was careful and explicit about that. I wanted it to throw that information in this case, but I can tell you that over and over again, people get that part of things wrong. They resample when they don't intend to, and they end up adding or subtracting pixels to an image which is a very damaging process for no good reason. So if you learn nothing else from tonight, learn to be extremely careful with the most dangerous control in all of Photoshop, which is this very innocent looking checkbox that is resampling. Okay, so now that I have created my image, I have got one important step closer to specifying what I want. You know, I have an image of colored pixels. I have set it to a particular physical size that I want the print to be, and I may have resampled for reasons of matching the print header resolution. I have, you know, I am now one step closer. I have a grid of dots, and I have a tag in that file that specifies the exact physical size for the print that I want. I've just got a little note here. It says upsizing by Magic AI. you know, when a recent occurrence is probably just worth mentioning because someone is bound to ask the question. Resampling is changing quite a bit. In the old days, resampling up was really just a case of sort of pixel stuffing. Photoshop would use very crude maths to just shove more pixels into your image. So you couldn't really fundamentally upsize an image. Well, in the last couple of years, we have seen some pretty transformative stuff going on in image sizing. You may be aware of a new feature in Photoshop called super resolution. It's coming to Lightroom as well. It also, there is Topaz, gigapixel, I think it's called. Basically, these are new mechanisms for upsizing images, for resampling images, for doing very large enlargements, where they use artificial intelligence to create the extra pixels that we need. It turns out that's really pretty effective. For many of us, the purists amongst us, you know, don't like the idea that these pixels can sort of randomly appear in our images, but it has to be said that one can see from the results of these new technologies that it is now finally possible to do really nice, very large enlargements from relatively low resolution images. So that's an interesting area of recent development. Now, when you're specifying the print that you want, you can go one step further. You don't just specify the size of the image that you want, but what we want to do is actually specify a canvas, i.e. the full physicality of the print that we want, or the print that we're sending to our own printer. And at this point is where we're beginning to approach the file as a complete specification for what we want. Now, canvas really just means an image plus some surrounding white space that determines the actual physical size of what's going to come out of the printer. Image plus white space, and here when I'm talking about white space, I am specifically talking about white pixels that have an RGB value of 255, 255, 255, which is the only value that is actual white space that says to any printer, anywhere, anytime, do not put any color or any ink on the page in this area. So just to finish off our little example of image sizing, I have here, I have created my 10 by 7.5 inch print. Now I might actually say I want to print this on an A4 sheet of paper. And I know that an A4 sheet of paper is 297 millimeters by 210 millimeters, but I want to print my image in the classic way where the image is slightly raised up on the page so that I leave a little bit of room for signing. Now, you know, I could try and explain that to my printer or move it around, you know, in some sort of print preview window or, you know, send an email to my print service provider and say, that's what I want. None of that's really good when I can precisely specify that in my own digital file. So here I might go, I want the canvas now to be 297 by 200 millimeters, just smaller than A4. I click OK. Photoshop creates the white space. Creates the white space for my image, and now we get a sense of how it's even going to sit on the page, the physical nature of the print. We then can actually do a second step where we take that out to the actual size of an A4, which is 297 even, learn to type, by 210 millimeters, and I'm putting the extra white space. I've used this little control here to say to Photoshop, put the extra white at the bottom. And then we click OK. And lo and behold, we now have a complete physical representation of what we actually want to get out of our printer. It includes the image itself, plus the physical canvas that we want to print it on, in this case, an A4 sheet of paper. It is the precise specification of what we want in every way, although obviously I haven't gone into a great deal of detail about color yet. So that's where we are at the moment. We have our XY grid. We're storing that in an appropriate file format, probably a TIFF, at a high bit depth, 16-bit, so that we can, you know, do aggressive edits and we won't run into image quality problems like banding. We have then used that to prepare our image to a particular size. Possibly we've changed the resolution through resampling, and then we have placed it on a canvas that completes the physical specification for the print that we want. What's missing? Well, of course, it's color. And I have, in many ways, grossly oversimplified colour to this point. And the reason that I've done that and the reason I've talked about all of this stuff is because in reality, most people's problems, although they worry about colour greatly, most people's real problems with digital prints come in those fundamental areas and the fundamental mistakes that they make in those real basics of preparing a digital image. If you don't understand that, you don't really have a hope of getting the colour side of things right. So you really need to get the basics nailed down and clear in your head as to what is a digital image, how does it hold pixels and colour, and how does it specify size and so on, so that you can get what you want from your printer. So that said, how do we specify colour precisely in our digital images? And again, it's worth repeating. If you cannot accurately see the colour you have and the relationships, particularly the relationships between the colours in your images, then you really have no chance whatsoever of specifying colour in the way that you want, of being able to say, these are the exact colours I want to the printer, you know, and therefore get back the exact colours that you want. You know, in the old days, there were other systems for this. There were systems like Pantone, which, you know, that's just a disastrous system. I won't go on about that, but basically the idea in the modern world that you would use like a physically printed book to specify colour, not worry about what's on the screen over here. Don't worry that it looks, you know, too orange over here. Just look at this tiny little swatch in my swatch book. You know, it's not the dark ages anymore. We don't need to work that way. We have good quality modern tools. You know, BenQ produce these insanely wonderful and accurate monitors for us. If we have those on our desk and we can see what we're doing, then we can actually, you know, get what we want. So, XY grid of pixels, color dots. It's too simple, obviously. You know, in actual fact, each pixel is stored as 3 values: a red, a green, and a blue value. You know, this is only one way for computers to represent colour, but it is the most common way and the most correct way if you want to specify colour. The value for green, the value for red and blue, they're mixed together. You start at black and you mix those together, and they are the colours of the light that you're mixing together, and you ultimately get the colour of the pixel that you want. This is called additive colour because you're adding the colour values and moving away from black. You should always use RGB if you are a photographer or an image maker or basically anyone specifying colour. You should never use CMYK. This is, you know, more than any of my other frustrations with the digital imaging process is photographers should never use CMYK. They should never be asked to supply CMYK values or a CMYK file. For one thing, there are entire companies devoted to the process of converting RGB images to CMYK files. They're called pre-press companies, and you know, they exist for a reason because they're, you know, better at that than the typical photographer. But the main reason you should never use CMYK ever in storing your own files and so on is because CMYK are ink values. They are literally ink percentages. You know, they're saying put down 70% magenta, 30% cyan, and 40% yellow. It's crazy because you do not know the ink values required to actually produce that color on a piece of paper. You don't even know it about your own printer. I honestly think you would find it almost impossible, even if you own a lovely Epson fine art printer, to actually find out the CMYK values that that printer is using. You certainly don't know it about the printer of some printing service that you might be using, say Image Science or whoever. You will never know that. So specifying color as ink values makes no sense at all. Never use CMYK. So assuming we're using RGB as our color model, so we're storing all our colors as red, green, and blue, we then need to talk about what are called color spaces. Essentially, color spaces are a solution to the problem that the RGB numbers on their own are essentially meaningless. So if we take an example of a single color, 255 red, which is, if we were looking at an 8-bit file, 255 red is the maximum red value we can have, or the most saturated red. What does that actually mean? If we just have the number 255 to represent red, it doesn't really mean anything, because when we put it on, you know, my monitor here, and we send that straight to the monitor without any color management or without thinking about color spaces, 255 red is a very saturated red because my monitor can display very strong reds because it's a wide gamut monitor. On the other hand, if I look at, 255 red on my phone, it's going to be a different color. And if I send 255 red to my fine art Epson inkjet printer, it's going to be quite a different color again. So RGB numbers on their own are not a good way of specifying color. They are essentially meaningless numbers. So color spaces, which are color space is another name for a profile or an ICC profile. Again, they're really just a little bit of metadata attached to the image. And really, they are a set of tables that give distinct meaning to the color numbers that we have in our files. So in other words, instead of our red 255 being some abstract color of red that might be determined by our monitor, or it might be determined by our printer or phone or whatever, we say instead, when we attach color space to a file, we say, no, this particular red 255 is this exact color. And when I say it's this exact color, basically we use a mathematical language called lab to define what that color is. So a profile takes all the RGB numbers we can possibly create and defines what they are in this mathematical language for color that's known as LAB. Now, I'm definitely not going to get into LAB because that is complicated and it tends to confuse people. The important thing to understand is a color space, whichever color space it is a table of values that simply defines what all the color numbers in the files actually mean. So in other words, a file, a bunch of RGB numbers in a file without a color space, and that is more formally known as an untagged file, that is a very dangerous thing. It is absolutely useless to send an untagged file to any printer because you are not telling the printer what color that you want. You are failing the basic process of specification. So in Photoshop, when I save an image, or any other image application for that matter, there is this really crucial thing down the bottom here that you can see, ICC profile, Adobe RGB. If I were to not have that box ticked, I would be telling Photoshop to save my image as meaningless color numbers. And if I then send that to a printer, I would have no right whatsoever to expect to get back what I want because I am just throwing the numbers into the wind. I'm not telling the people at the other end of this process or the physical printer at the end of this process what those colors means. So it is essential that we tick this box, that we create tagged files. Photoshop has this nice little information panel down the bottom here. You can choose different things. I always have it set to show the document profile, and it will show me the color space that is attached to my image. Now, I like to think of color spaces as dictionaries. So it's showing me the dictionary for color that I have attached to my image. So let's talk about color profiles and the different types of profiles there are. Input profiles, which we've already said we're not talking about today. Basically, those are profiles that seek to improve the accuracy of color coming out of our camera or scanner. They're a bit complicated and a bit different from the others, so we won't talk about those. Next, we're going to talk about output profiles, which are color spaces which define very precisely the exact colors that will come out of our printer when we send them specific colors. And then finally, we're going to talk about working spaces. Printer profiles are really quite simple. All they are, again, is a table of values. And basically, what that table is if I send, these colors to the print, these RGB values, so these pixel values from my digital file, if I send this pixel, such as red 255, then my printer produces this actual color. And then from then on, once we know that, and we've measured that out of our printer, we can actually reverse that table. And we know from then on, if we want to get that particular shade of red, then we need to send the red value. It doesn't really matter how it works. Take it as a given. What a printer profile does is it allows us to produce accurate color from our printer by translating the numbers that we are sending to it, the numbers in our images, to the best matching colors that the printer can produce. There's two types of profiles that you commonly come across, stock ICC profiles and custom ICC profiles. Stock profiles are the ones that you get from paper makers. So say, for example, you buy a really nice fine art paper from Ilford, and you go, oh, well, I want to get nice results out of this paper, and everybody says I need an ICC profile. So you go off to Ilford's website and you download the profile. At least 50% of people miss the next step in that process. And this is a key thing about understanding printer profiles. Printer profiles describe accurately the behavior of a printer in one state and one state only. That is, you must know the exact driver settings that a printer profile was created for, or you cannot use the profile. You can put the profile into Photoshop and tell it to use it, but it will not accurately describe what your printer is doing unless you're using the exact settings the profile was made for. So whenever you download a stock profile from a paper manufacturer, you must also download the instructions, the printer setting instructions that go with that profile and use them. And I know for sure, having answered tens of thousands of questions about that particular topic over the years, that at least 50% of people who go to the effort of downloading profiles because, you know, they think that that's how they get good color, do not download the matching settings and do not use the matching settings, and therefore are not using the profile at all. And that is the basic explanation as to why so many people go, oh, my printer profiles, you know, didn't work. I downloaded from Ilford and, you know, it just didn't work. It is because you are not using it properly. You must use the settings. And that is sort of in a way brings us to custom profiles, because custom profiles are the alternative to that. You don't just go off and download this thing from the paper manufacturer, but instead you measure the actual behavior of your specific printer on a specific paper. And you create a really, or usually it's a service, someone like us, we create for you a really high quality map of the color that your printer produces. It's a characterization. And again, going through that process, it causes you to understand that what we are doing is describing your printer in it and its behavior with one specific set of settings and only those settings. And that's one of the advantages of going through a custom profile process, is that you learn that the profile and the settings are completely related. They must be used together. And it's an essential part. You know, people are sort of still getting custom profiles on, you know, print providers and people who are really seeking high print quality, because there is no better way of getting accurate color out of a printer. Now, if you're doing your own printing, it's my advice that you get custom profiles for all of your favorite papers. On the other hand, if you're using a printing service, then they should be able to give you their profiles. We certainly do. Any decent quality printing service in the world today should be able to give you an accurate profile that tells you what is going to come out of their printer. I'm mindful of the fact that I'm running over time, so I'm trying to speed up a little bit, but I'm going to talk now about working spaces, because yeah, this is a key concept and one that you need to be careful, right? You know, we have these printer profiles, for example, and we're calibrating monitors, so that we also know that we're creating monitor profiles, hopefully. It is tempting then to go, oh, I've calibrated my monitor, so I should work on my image in my monitor's color space. And again, we routinely see people sending us files with their monitor profile attached. You don't want to do this. You never want to tie your color to one particular device. You know, you don't want the color information that you're storing for the long term in your lovely captured photograph to be determined by the printer that you currently own or by the screen you're currently viewing your image on. You want your color in your files to be independent of the devices that you use. And for that reason, there are these things known as working spaces. In this context and in the RGB world, you're really likely to only come across 3 color spaces: sRGB, Adobe RGB, and ProPhoto. You could think of them in a way as small gamut, medium gamut, and large gamut. It's probably beyond the scope of here to really get into this too much, but I will just mention there is a tendency lately for lots of people to use ProPhoto for everything. This is probably because by default, for example, Lightroom will export images into ProPhoto and so on. ProPhoto is a massive color space and it is usually needlessly large. Its gamut, so the range of colors it can represent, is very, very large indeed. And it can actually create problems. Now, I won't get into why that is. There's a long article on our website as to why that is. But one little thing that I do like to point out to people is when you when you export an image from your raw converter, you can then bring it into Photoshop and look at your histogram. And you can see by looking at the right-hand side of your histogram whether or not you have any color clipping, whether or not the color space that you've exported into is big enough for your needs. Smaller color spaces are smoother, and I don't really have time to explain that in detail, but there is a basic rule that the smallest color space that fits an image's colors is the best color space to use for that image. So my advice to you is when you go to export your image, by default, export into sRGB and then open the image in something like Photoshop and look at the right-hand side of your histogram. If you do not have, and I'll just go back to the one without the white in the image because it's a bit clearer. If you do not have a bunching of the histogram on the right-hand side in the color channels, in the red, green, and blue here, you don't have any color clipping going on due to your color space, and it would be fine to store that image in a small color space. This image, which is reasonably colorful, fits absolutely fine into the medium color space, Adobe RGB. In reality, it would probably even fit into sRGB as well. But the smallest color space is the best working space to use. Okay, going through it again, X by Y grid, RGB color values. We now make sure that we have a dictionary for those color values attached to our file by saving the tag. For a file, it will be our working space, Adobe RGB, sRGB, or ProPhoto. And at that point, we truly have a complete specification. We have an X, Y grid of dots. Each of those dots is a red, green, and blue color number. We have a dictionary attached for what those color numbers mean. We have specified the physical size of the print that we want and even the white space around the print that we want. We have a complete, fixed, non-interpretable, absolutely precise specification for our file for print. And it is that exact thing that any printer wants to receive, whether it's your own or a printing service. So actual printing is really taking that, that precisely specified thing that we have created and getting it out of the printer, usually using a printer profile to get the best matching colors. Now, in general, that's how it works. For about 95% of the images, you can simply take the image that you have precisely specified, throw it at your printer using the accurate printer profile that you have, hopefully the custom profile. You might experiment with rendering intents such as perceptual and relative color metric. And 95% of the time, at that point, you should get a great screen to print translation going on. You should not have any major surprises. But the reality is that there are times when we need a little bit more than just trusting in the profile. And for that, we use soft proofing. Soft proofing is a fundamentally difficult process. It's fundamentally difficult for the tools that we're using to do properly. And this is because no matter how good color management is, no matter how expensive and fancy your monitor, the reality is a monitor and a piece of paper are two fundamentally different things. You've got, this light emitting device that's really good at high contrast. It's fantastic at pumping light straight into your eyeballs, very high contrast, versus paper, which can only reflect light, emits no light at all. It is a dull, boring medium in some ways. So, that's why it's such an art form to get a good print out of it. It is difficult. In theory, when you have a properly specified image and you turn on soft proofing in Photoshop, i.e. where you turn on Photoshop's simulation of the printed output, this is in theory what you see is what you get part of printing. That is actually, if I go into Photoshop and I say, okay, I want to print this file and I am going to print it on a particular type of paper. I've already got something selected here. And, I toggle that on and off. I can see what changes are likely to occur when I send this image to my printer and whether I'm likely to run into any dramatic problems. That process is generally pretty effective. However, it works-ish. The problem with soft proofing comes from the way monitor profiles are built. So they go back and they haven't really changed in about 20 years now. It is a fundamental problem in the maths of colour management as it exists, that the contrast of your monitor is not recorded in your monitor profile. So when you want to match a print between screen and print, the most important thing, even more important than colour, is getting a match between the overall weight or brightness or density or contrast of an image to match between screen and print. And because a monitor profile does not tell you, or tell Photoshop for that matter, what the actual contrast of your monitor is, Photoshop has to guess what the contrast of your monitor is. And Photoshop makes the same guess now as it did 15 years ago, even though monitors are increasingly bright and have higher and higher contrast. Photoshop just fundamentally gets it wrong. It takes this wild guess about what the difference, it assumes that your monitor is very high contrast, that your print is very low contrast, and it tends to massively overstate how much loss of contrast is going to occur between screen and print. It's not really Photoshop's fault, to be fair. It's the fact that monitor profiles don't have this information, and thus it's not available to Photoshop. But this sucks, and this has been a big problem in soft proofing for as long as it's been around. Fortunately, monitor makers have come to our rescue here and have recognised this issue. And for years I've been bugging BenQ to add this particular solution to their calibration software, Palette Master Elements. They have now done so. I think it was late last year, they have added it to it. And what they finally allow us to do is, instead of using Photoshop for the contrast part of soft proofing, we now do it in hardware. So Palette Master now has the ability for us to specify a contrast ratio, or a contrast ratio as, contrast ratio is white divided by black. So by specifying a brightness for white and a brightness for black, we are determining the contrast that the monitor will show to us. Now, what makes this so great is we can set a high contrast, our naturally high contrast monitor, we can tell it to display significantly less contrast. Instead of its native contrast, which might be 1000 to 1, we can say, no, show us more like 200 to 1 or 180 to 1, because we want our screen to look as much like print as possible. So we can address contrast in hardware now, as opposed to using the fundamentally broken soft proofing facility in Photoshop. And this is a revolution. As soon as you start using this, soft proofing really does get to that sort of what you see is what you get process or point where, because you can now see the contrast accurately. Now you can still use soft proofing in Photoshop. Here we go back into proof setup. And we no longer use this bottom part of the dialog here, that's the contrast part. This top part is still showing us the color, and it will still show us the color changes that might occur between screen and print. But we're no longer using Photoshop to show us the contrast change that might occur between screen and print. Instead, we're doing that in the monitor's hardware. It's much more effective, and it is a fantastic new feature in Palette Master Elements. So if you haven't downloaded an update recently and you are lucky enough to be a BenQ owner, make sure you grab that update and start using it. I realise I've attempted to cover far too much in this lecture, and I have rushed a bit through it, but I'm just going to finish off with a couple of common problems that always come up, and these were questions that I saw were asked before we did this, and it's just worth addressing in terms of how do you get things to match between your screen and your print. The single most common problem that people run into is that they will say, my prints are too dark. That is easily the most common problem in digital image. People send things to their own printer, or they send it to a printing service, they get it back and it's darker than they expect. There are really 2 or 3 main reasons for that. The first and most fundamental is that your monitor is probably too bright. You're either not calibrating your monitor, or you're calibrating it to too high a brightness point. If you're trying to get your monitor to look like paper, the most fundamental thing you can do is reduce its brightness significantly. So for example, if you're currently calibrating to 120, your prints still seem a bit dark, try recalibrating to a lower figure. The other end of the problem might be how you're looking at your prints. You know, color management and printer profiles and so on, they are built to show you what your prints are going to look like under a proper print viewing light, under really good quality, relatively high lux lighting. A lot of people simply compare their prints to their, they might be working in a relatively dark office environment, and they're just looking at their print in this sort of really quite dark light, and they're concluding that the print is too dark and isn't a great match for their screen. When in fact, if they just went and put their print under a decent light, they would find that there was an excellent screen to print match, in fact, going on. So normally that problem comes from your monitor being too bright or the print viewing light being too dark. And BenQ have this lovely lamp. You can see a picture of it there called the WIT lamp. It's relatively inexpensive and is actually a really good quality print viewing light. And I strongly recommend that you get a good print viewing light. Color purity is another thing that people ask me about regularly. They're often frustrated by when they see, what better photographers or better printers producing images that have a real purity and depth to their color that their images are lacking. They're saying, oh, my images always look a bit muddy, I can't quite get that, and so on. More often than not, that specific problem is coming from getting your white balance wrong. And again, that really comes back to having a great monitor properly calibrated, because if your monitor is even a little bit out, it is extremely difficult to choose the correct white balance in the raw conversion process. Now, you can solve that problem in another way. You can use a white balance target, and you can take a shot of it, in the same light that you're going to take your final shot, and use that in your processing. And of course that works. But the reality is most people don't do that. It kind of interrupts the photo workflow. You don't always have a white balance target to hand. So the crucial thing is you need to be able to see your image really accurately on screen, and make an excellent decision about white balance, because your color pollution problems, your weird slight color class in your shadows and so on, they're mainly coming from white balance errors. Even a few hundred degrees Kelvin can make a significant impact on color purity. So having a great monitor and calibrating it really regularly, at least once a month, allows you to keep things running in a tip-top way and make the best decision about your white balance. Another color issue that people run into, and I'm asked about all the time, is why can I not get my backlit image looking right in print? So a backlit image is something like, you've got a model standing in front of the sun and light is shining through her hair, and it's making that lovely sort of lit up halo effect, and so on. Well, the main reason for that is because it's really difficult to translate that sort of image between screen and print, because your screen is is in sympathy then with the image itself. Your screen is a light emitting device, and your photo looks good because it looks like light is coming through it. The reality is that is probably not that solvable a problem. No amount of fancy technique and better equipment really solves that. The reality is some images look great on screen and don't look good in print. That said, with those ones, getting really precise adjustments to your image contrast make a really big difference to the actual final printed outfit. And that again probably comes back to having a great monitor, and one with a hardware contrast control, as I was just talking about a moment ago. I think I might skip over that because we're running out of time. I guess the important thing to understand about all of this, though, is that the color management it works, and it works quite well, but it is not a panacea to all color problems you're going to have. And learning to print is partly about learning these technical things about specifying what you want, getting your files correct. But then it's also about making a lot of prints and really analysing and looking deeply at other people's prints. This is, again, one of my favourite things to tell people. The biggest, I think, mistake people make in photographic learning is they actually spend too much time shooting and processing their images and not nearly enough time at looking at really great photographs and analysing exactly what makes them work, what makes their great photograph tick. And, there are, old school printing things that you still need, even with great color management and so on. There are little tricks that it's worth learning, and you don't really learn about them until you print. For example, this is a technique known as a ring around that comes from the darkroom days, but it's not something you learn about. If you really want to take an image and get the best from it, it often comes down to making very small adjustments that you need to be able to see accurately on your great monitor. But sometimes even then, you can't really get a feel for what they're going to look like without actually making a print. And then it might be really useful to you to do this thing like this thing here called a ring around. Now, you probably can't see this across Zoom or on a recording, but there are very subtle differences between these 5 images. You know, and what a ring around does is it shows you, if I add just a little bit of warmth or just a bit of cool down, or I darken this bit, or I do that, you know, what effect does that have on the image? And you can do this, and you can actually do multiple versions of this, going, okay, based on this first ring around, I like the slightly warmer view of my image, so I'm going to do that, but I actually also quite like it being a bit darker. So then I'll do another ring around where I'll do a few more images that are a bit darker and a few that are a bit warm. It's a great printing technique, but it's the sort of thing that you will never really learn to do unless you actually make some prints. You know, to make great prints, you must do printing. But that is also, you know, a huge part of the fun. That's where, you know, to me, a huge joy in photography comes from, is all of those decisions and all that technique and all that equipment. It culminates in the creation of this beautiful and hopefully accurate, and hopefully, you know, this print that matches exactly what we want, because we specified as well as we possibly could what it was that we wanted. For the very last slide, I'm finally getting there. I am definitely over time, drastically. Let me just quickly talk about the BenQ SW271C, just because this is a fairly exciting new monitor. There aren't many great 4K color accurate monitors on the market. I believe now that, although I have been saying for years that 4K isn't that important, I think we're getting to the point now where really it is fair to start expecting from monitors that we're going to have 4K. Therefore, we want 4K color accurate options. ASO have one, but it's really quite expensive. BenQ have an older model, the SW271, really popular. It was pretty good, but the new model is excellent, and we have just finished a really long evaluation of that, which you can find on our website. But it's really worth knowing that this monitor is a significant improvement, particularly in the area of uniformity. It has some hardware features like USB-C with power and so forth, but it is a really excellent effort from BenQ, and many people want a 27-inch 4K monitor. If you're trying to specify your files for print, that is exactly the sort of tool that you want. So go check out that evaluation, and I think you'll find it interesting, and hopefully it helps you or achieve better prints. Richard, Ivy, do you want to grab things back and we can do some Q&A? There's still some time.
Yeah. Thank you, Jeremy, for your great insights, and we hope everyone has enjoyed this informative session. And we are going to answer the questions in Q&A chat room. I'll start from the top. Bob asked, how often should you calibrate your monitor?
Okay, the typical recommendation is about every 200 hours of monitor use. It's roughly that figure. That is, monitors drift through use. So the number of calendar days and whatever doesn't really matter. It really matters how much you use your monitor. Good monitors like the BenQs, they have timers in them, and they actually give you a reminder when it comes time to calibrate your monitor. But I will say, for most people with a typical amount of usage, you want to be calibrating at least every 2 months, and I would generally say about once a month. Given it only takes about 5 minutes, it's a process well and truly worth the time.
Okay. And next question is, what is the difference between PPI and DPI?
Okay, pixels per inch and dots per inch. Well, really, the only term that you as photographers and so on really need to be thinking about is that pixels per inch. How many pixels from my original image do I want to map to an inch of actual physical print? Dots per image is a legacy term from the printing word. It actually talks about how many physical dots of ink the printer can lay down for an inch. It actually doesn't have much correspondence at all with PPI. Which is the important figure that is what determines print quality. DPI, because of inkjet printers and so forth, they use what's called a half-tone matrix. They in fact mix many little dots to make the equivalent of 1 pixel. it is almost irrelevant what the DPI of a printer is. You'll see Epson quote their printer. They go, printer is 5,760 by blah, blah, DPI. It's meaningless because, yes, those printers have very small dots, but they actually have to use a whole bunch of those dots to represent a color. So the real figure that you need to know is PPI, or no one understand, it's PPI, not DPI. In all honesty, just ignore DPI altogether.
Okay. And next is Joe asks, what process do you use to copy a raw file to do your edits on? Do you save an unaltered raw file as well?
Well, no. Yes, I do. I mean, the raw converter does that for me. So, you know, the basic workflow is I import the photos from my camera. I have the raw file in my raw converter. I might build some edits on top of that. But in a raw converter, I can always go back to the unaltered raw file. So other than the fact that I back up the raw file, you know, to the cloud and so forth, I don't, you know, store some other copy outside of my raw converter. I have, you know, the beauty of the raw converter is all of the changes that sit on top of your raw file can be reversed. I can go back to that original raw file at any time. So that's essentially built into the raw converter.
And next is Ian asks, when you resampled and it offered 401 PPI, why did you not use what it offered? Was it a case of saving ink?
No, so it really has nothing to do with ink there. It is the reason I didn't use 400 was because I know the native resolution of my Epson printhead is 360. And in reality, the reason I wanted to use 360 and not 400 was because there can be weird mathematical artifacts when you send odd resolutions to the printhead. So for the sharpest possible results, it's usually best to resample to the native resolution of the printhead. In the case of Epson printers, it is actually technically 720, not 360, as I said, although the difference between 360 and 720 is extremely hard to see. So it's kind of standard practice to use 360 with Epson printers. In the case of Canon printers, the figure you're looking for is 300. But the point of it was to avoid weird scaling artifacts when the printer prints the image, to be honest.
Okay. And next is, are PNG files okay to print?
They are not okay to print because PNG files don't store color profiles. They are completely inappropriate for print use. They are a web-only file format.
Okay. And next is, what color space is predominantly used in Australia?
Oh, I don't really know how to answer that one. These days, I would argue that I would guess most people effectively are using ProPhoto most of the time because their raw converter. Lightroom is easily the most popular raw converter, and Lightroom in the background is essentially using ProPhoto. And we're increasingly seeing people export. Look, no, in reality, most of the print files, probably Adobe RGB. In short, Adobe RGB.
Okay. And Alison asks, I have a BenQ monitor and Canon Pro 1 printer. My colors are good, but I always have to add a brightness layer with brightness. Yeah,
so that's the classic issue that I kind of hopefully addressed in the seminar itself. But Alison, if you want to get into that more detail, just shoot me an email and we can go through your specific situation. But almost certainly you want to calibrate your monitor to a lower brightness and or look at your prints under a really nice lamp like the BenQ Wit lamp.
Okay. And next is Peter asks, is it better to print to your printer via Photoshop rather than Lightroom?
It's not really better. Lightroom has a somewhat easier print workflow, and you can use ICC profiles with your printer and so on. So in theory, you can get the same print. But Photoshop allows you much more control over the physical specification side. So where I did that whole thing with laying out the canvas and so on, Photoshop is much better at that than, say, the Lightroom template. Quite frankly, the Lightroom template system is a horrible kludge. And if you really want to do things precisely, and particularly if you're working with making the best prints of single images, Photoshop is still the best tool for that. So yeah, I think it's a good way to go.
Okay, and next is Alison asks, I have a BenQ PD2700U 27-inch 4K monitor and a Canon Pro 100 printer, and find the printer prints different color to what I see. What can I do to fix this?
it's probably not enough information to answer that one, but in a nutshell, I would say if you're not calibrating your monitor, calibrate your monitor. If you're not using custom printer profiles with a printer, get a custom printer profile and go through that process. But yep, that's a sort of talk about offline type one, but I'm happy to go through that with you. And as, you know, if you really want to understand all of this, the Fundamentals of Digital book on our website takes you through all of this stuff in much more detail without skipping over all sorts of things like I kind of had to tonight to try and cram it all in. Yeah, you know, that is definitely a solvable problem. It is a very common problem, but definitely solvable.
Okay.
Yeah.
And next, Steve asks, how does Photoshop use the color master element contrast value for soft proving? Does it just happen automatically?
Well, essentially, yes, in the sense of it happens because we explicitly turn off the contrast part of Photoshop's soft proofing. So we turn off the controls which are called simulate paper white and simulate ink black. That's essentially where Photoshop is simulating the contrast. We turn that off and we only do the color side of the soft proof in Photoshop. And our hardware is set to the right contrast. And therefore we're seeing the color proofing bit is done by Photoshop. The contrast bit is done by the fact that we've adjusted our hardware, and therefore, in that sense, it is automatic, and it works really, really well. If you're used to traditional soft proofing and you move to a hardware-based approach, it's a bit of a revelation. It's so much better.
And next is Wayne is asked, I calibrate my printer with i1 Pro 2 and iProfiler. How many patches should I use? I usually use 2035. Is it enough or too many?
That's a really good question, Wayne. As in, look, in reality, most people use about 1,000 patches on average, and that's usually enough where you have enough signal and not too much noise. If you had a more complex to profile thing like a CMYK, a proper CMYK press or something like that, you would probably want to use a lot more patches. You probably use about 4,000, something like that. But in reality, most RGB printers are characterized quite well by around 1,000. And honestly, measuring more than that is probably getting to the point where you simply don't need to. So my advice is it's probably around 1,000. That happens to fit very nicely. If I hang on a second, if you can see over my shoulder there, you can see a color target. That's the standard Image Science over there, color target with 1,000 patches. That's what we use in our commercial profiling service, and we do not get complaints. So I think that is, you know, modern printers are fairly, well, high quality modern printers are fairly well behaved. So you don't need as much data as perhaps 5 or 10 years ago, or no, 15, 20 years ago with lower quality printers.
Okay, and next is Anton is asked, when I calibrate my monitor, all my images look very blue and completely different from any other screen I have. I just run the auto setting on my BenQ. Can you point me to what I might be doing wrong?
Anton, I don't have enough info to answer that one. My guess is you might be calibrating to the wrong white point, for example. If you're calibrating, you know, to some value above 6,500 Kelvin, your screen would, you know, you would get a very blue result. Yeah, I don't have enough on that one. Feel free to give me an email and we'll talk some more.
And next is Adam asks, does a file need to convert it to 8-bit for printing?
Yes and no. No, it doesn't. Modern printer drivers are usually 16-bit and will quite happily accept a 16-bit file. So in reality, inside the printer driver, it's almost certainly down converting it to 8-bit, but you don't need to know or see that. So sending a 16-bit file to a printer is fine. Luca, the slide, I can read these questions. Do you want me to read them in fact, because they're coming up? Okay. Luca is asking, she was curious about the slide that was skipped. That was a slide about, you know, well, that was well observed, first of all, but it was a slide about the difficulties in dealing with neutral, so black and white images specifically. There's a natural tendency to think, because we have great color tools and these fabulous monitors and so on, that somehow black and white images will sort themselves out because, you know, color is more complex than black and white. Well, it so happens that color management doesn't actually work very well for black and white images, because color management is all about the principle of reducing average error. So as a quick explanation, when you calibrate a monitor, what it does is it looks at all the colors the monitor can display and it tries to reduce the average error across, you know, thousands of tones. It doesn't seek, for example, to necessarily make your neutrals as perfectly neutral as possible. So even post-calibration, there is a little bit of error that remains in certain tones. And if you happen to be working with those exact tones, your eye is actually really good at seeing those problems. And really, it's hard to discuss without getting into detail, but which is why I skipped it. But in a nutshell, probably the hardest thing to get right about screen to print matching is, in fact, black and whites, or even better is, or even more difficult is black and whites that aren't truly black and white. It's those ones where you want just a little bit of tone in your image. Those are spectacularly difficult to get to match between screen and print. And there's really no fix for that, simply because it's kind of built into the way color management works. Well, really, to put it another way, the only fix for that is test printing. It's one of those areas where you simply have to print to solve the problem. Okay, an anonymous attendee says, early on you mentioned a calibration tool. Which one was it? I mentioned the i1 Display Pro. Essentially in the calibrators world, there's two big brands, X-Rite with their i1 Display Pro and Datacolor with their Spiders. I am a huge fan of the X-Rite device. It is far more accurate over the long term than the Spiders. The X-Rite i1 Display Pro is, to me, the only logical calibrator to buy on the market today. Wayne Smith says, to calibrate a monitor, should I reduce contrast to 0 and then adjust brightness, or raise contrast and lower brightness? Honestly, you should do neither of those things. You might do something a little bit like that if you're doing software calibration, but no sensible calibrator would take that approach. In general, if you're doing software calibration, so you're doing a traditional monitor, one that doesn't support direct hardware calibration like, say, the BenQs do, you know, if the software's asking you to do that, it's a really old-fashioned approach. You wouldn't really do that with a modern LCD. So in a nutshell, I would factory reset your monitor. I would use it at its default contrast, not change contrast during the calibration process if you're using one of those older or less good software calibration things. But really, Wayne, if you want to get more about monitor calibration, go to the either our YouTube or BenQ's, where we did a whole seminar on monitor calibration, and you can see us go right through the process and discuss all the settings in detail, because it's probably a bit too much to get into. What tells the monitor to switch to the paper contrast? Nothing does, as in, well, that's what you do when you define your calibration target. So when you do the calibration, you told it the contrast you wanted to display at. So the monitor is essentially permanently at that contrast. And you don't need to switch to it. That's a follow-up question to the one earlier. But basically, your monitor, we fix it at that contrast. We do all our editing, at that contrast. We're seeing that contrast all along the way, and that's something called early binding, which again, it's in that digital fine print if you want to go from there. My email. Just go to the website and use the contact form. I don't actually publicize my email out on YouTube and what like that, because I just get endless spam when that happens. So there's a contact form on the website. Please use that. You'll see that you can select who it should go to. The one where it talks about tech support, that'll go straight to me. So you can email me directly that way. And Alan, hi Alan, I haven't seen you for a while. I hope your P906 is going well. I have an i1 Display Pro, but it can only do 450 color patches, not 1000. Alan, I was talking about printers where I talked about 1000 patches, not screens. 450 color patches is heaps for a screen. So yeah, no, that's not an issue. And if I have misinterpreted your question, you have my phone number. Give me a ring tomorrow and we'll chat.
Okay, so I would like to say thank you again for taking your time to join us. The session was also recorded and will be available tomorrow. We'll be sending out an email with all the details on where you can rewatch the session again. And if your question were not answered, please feel free to contact us from the email we will be sending out tomorrow, and we will endeavor to provide a response to you as early as possible. And lastly, don't forget to help us fill out the survey after the webinar. Okay.
That's good. Look, I want to say, just before I go, I've got a cold. I'm actually feeling really not great. And I hope that made sense. It was a lot to cover in a really short time. I halfway through, I found myself thinking, God, I really went a bit crazy with the planning here. I should have done that as 2 separate sessions or 3 or 4. But I hope that there was some interesting material. And as again, I'm really open to follow-up questions and so on. So feel free to contact us through the website. And you know, I love talking about this stuff, and I'm happy to help.
Thank you, Jeremy.
No worries. Thank you.
Okay. See
Great.
you next time.
See ya. Bye-bye.
Bye-bye.
Bye, everyone.
Bye.